Okay, welcome. Now for the definition of the quotient, the difference quotient. So it says, let f be a function defined on an interval I containing a. If x is not equal to a is in I, in the interval I, then q equal to f of x minus f of a divided by x minus a. So in other words, the slope of the secant line, right, is a difference quotient. Also, if h is not equal to 0 is chosen so that a plus h is in the interval I, then this quotient, f of a plus h minus f of a divided by h, is a difference quotient with increment h. Now, both of these difference quotients can be used and are used for finding the slope or approximating the slope of the tangent line with a given secant line. Okay? Which one that we use really depends on the setting and how easy it is as far as the ease of the calculation, but both of them can be used. Okay, now remember that what we're doing is we're looking at 2 points on the line. The point that we're interested in finding the slope of the tangent line at, and another point that's close to this point that we're going to slide, or as we get closer and closer. So we have an interval, right? And as long as we're in the inside the interval, as that interval gets narrower and narrower, right? What's happening to the difference quotient? It's going to get closer and closer and closer to the tangent line. So this brings up the idea of the limiting process, right? So if I was to take either one of these and say, hey, what happens to the limit of this thing as x approaches a? Right? So what happens to this function, right? We've been doing limits. We spent a lot of videos dealing with limits. Now we're going to use the limiting process to tell us, hey, what happens as x gets closer and closer to a? Equivalently, what we're asking is, hey, what happens to this function as the point x comma f of x gets closer and closer to the point a comma f of a? And so what we're going to do is we're going to use the limiting process. We're going to use limits. Also, we could use the limits on this one too and say, hey, what happens as the distance h gets smaller and smaller? In other words, what happens as the limit of this function as h approaches 0? Okay, same thing. Okay, so we're going to introduce the definition of the slope of the tangent line using limits in the next video, and then we'll do some examples.